Hello, everyone. Here are the solutions to the solving systems of equations by graphing worksheet. You had to do 14 to 24 and the number 26. So especially for my remote learners, please let me know if you have any questions. So keep in mind, when we do solve by graphing, we have to indicate, now for 14 through 17, if you didn't write out the ordered pair, that was fine. The question was only how many solutions does it have. But when we do solve by graphing, it's not enough just to show that the two lines intersect. We have to indicate where they intersect, so we have to write out that point of intersection. Now for 20, 22, and 24, there was no need to even graph these. If you noticed, we could tell if lines are parallel. That's the only reason we're going to get a no solution is because when we put them both in slope-intercept form, only the slope should be the same. If everything is the same, then they're not parallel lines. They're the same exact line. They're coinciding lines. So 20, 22, and 24 were all parallel lines, meaning all the slopes should have been the same. For 23 and 26, both equations in slope-intercept form would have been identical. So we had graphed one line right on top of the other line, which means we have infinitely many solutions. But those infinitely many, they're not just any ordered pair. They're all the ordered pairs or all the points on the line that are solutions. All right, so again with systems of equations, we always want to make sure we fully understand what it means for an ordered pair to be a solution. So I want you guys to pause the video, see if you can determine if this ordered pair is a solution to this system of equations. So what we want to be able to do is check both equations. The solution needs to satisfy both equations. So checking the first one, so check both equations. Now, if it doesn't satisfy the first one, there's no need to check the second one. So I'm going to check 2x minus y equals negative 8. So again, x is negative 3, y is 2. So I'm going to get 2 times negative 3 minus 2. Will that equal negative 8? I'm going to get a negative 6 minus 2. That equals a negative 8. Yes. So that means the point is on the first line. Now I'm going to check the second one. Now this is the opposite of a negative 3. Plus 3 times 2 equals 3. So this will give me 3 plus 6. 3 plus 6 definitely doesn't equal 3. So it was on the first line. It is not on the second, so it cannot be on both. So because this one did not work out, but the first one did, we would just answer an overall no. It is not the point of intersection. All right, so as I just mentioned with the homework, recall the three possibilities of solutions. We can get exactly one solution. We always want to state that as an ordered pair, or we state no solution. Writing parallel lines, that's not the answer. That's just taking place of graphing our two lines. So indicating they're parallel lines, you're just telling me you know what kind of lines they are. But the answer we want to write is no solution. Or again, writing coinciding lines is not enough. You're just kind of writing that in place of graphing. You want to say infinitely many solutions, but more specifically, all points on the line are solutions. So we already looked at graphing as one method to solve a system of equations. Today we're going to focus on the other two, a substitution method and elimination method. All right, so for this first example, we're going to solve using the substitution method. After a while, you guys are going to choose which method you prefer. To me, I think it's always easiest for the elimination method unless it's sort of set up for us to use a substitution. So when we use substitution, we either need to look for or get one of the equations to say x equals something or y equals something, or we have to solve for x or for y. So if I look at A, go ahead and copy that down, pause the video. I don't quite have x equals something or y equals something, but I can get it quite quickly from the second one. We don't want to cause more work for ourselves. We want to avoid fractions if possible. So I could rearrange this and solve for x simply by adding 3y to both sides. So this will become x equals 6 plus 3y, or I could have 3y plus 6. Now what I could do is take this 6 plus 3y, since it's equal to x, and wherever I see an x up here, I'm going to substitute that. So now I have a 3y equals 2, but instead of x, I'm replacing it with what x is equal to, 6 plus 3y, and then minus 12. So now I just solve for y. So we get 3y equals, distribute the 2, 12 plus 6y minus 12. Notice my 12s are going to cancel out. I'm going to get a 3y equals 6y, technically plus a 0 if that helps. I would recommend writing that in. Now I want to get my 6y to the other side. So if I subtract a 6y, I'm going to get a negative 3y, and now that 0 is very helpful. We need it there. Divide by a negative 3, so y is equal to 0. So right now, of my ordered pair, I have my second value. Now I need to find x. Well, guess what? We're going to use this version of it. X is equal to 6 plus 3y. So x is equal to 6 plus 3 times 0, which is just 6. So now my answer is 6, 0. And if I were to check it in both of these, real quick, 3 times 0 is 0, and then 2 times 6 is 12. 12 minus 12 is 0, so definitely checks in the first equation. In the second one, I'm going to get 6 minus 3 times 0, so that's 6 minus 0 is 6. So my solution does satisfy both equations. Now let's take a look at example B. Please copy this down. Right now, if you notice, the first equation is already solved for y, so we don't have to rearrange anything. What I'm going to do is replace the y down here with this quantity. So now I'm going to have 8x minus 2, but instead of the y, I'm going to have the 4x plus 5 equals a negative 10. Now I want to distribute the negative 2, so 8x minus 10 equals negative 10. And what's going to happen here, my 8x's do cancel, so I'm left with the negative 10 equals negative 10. Now we've seen this before with just single variable equations. When everything cancels, our variable terms cancel, we're left with a true statement. Wasn't that all real numbers? Well, in this case, all real numbers turns into infinitely many solutions, or all points on the line are solutions. So what we just did here was we found out we have the exact same lines. These are coinciding lines when this happens. If our x is canceled and we were left with two completely different numbers, this would be parallel lines. There'd be no solution. All right, next we're going to take a look at the elimination method. For me, I think this is a little bit quicker at times. The idea, though, is we want to get both equations. Now, it doesn't have to be in strict standard form. We just want to get our x's and y's on one side and our constants on the other. So for A, my first equation is already like that. 3x plus 4y equals 8. We're good to go with this one. In my second equation, I want to move the negative 12y to the other side, so this will become a 9x plus a 12y equals negative 36. The idea here is to either, we're going to have to multiply one or both equations by something to get opposites. So we really don't have, or we have a choice sometimes. I want to get, and again, we could choose, I'm going to get the x's to cancel. So I want to multiply the first equation. It'd be nice if that said a negative 9x, right? So I'm going to multiply that by a negative 3. And what I'm going to do is I'm going to continue to show my steps very neat and organized. I'm just going to keep moving over and then I'll move down. I don't want you guys showing your work all over the place. Be very neat and organized with it. So my first equation is changing. It's becoming a negative 9x minus a 12y equals a negative 24. My second equation is staying the same. Once I have this, though, I'm going to kind of draw a line here. That's the addition line because I'm adding things vertically. My 9x's are gone. And then take a look at the y's. They're actually gone too. So I have nothing left over. I have a 0. Now if I combine a negative 24 with a negative 36, that's actually going to give me a negative 60. So my variables canceled. I'm left with the false statement. What do you guys think the answer is? No solution. So this actually turns out to be parallel lines. If we were to try to solve by graphing these, they would be parallel lines. So we have no solution. Let's try one more. All right, if you notice, everything is lined up, x's, y's, equal signs, and constants. I just need to get a pair of opposites. Well, here if I look, 5 and 4, 4 doesn't go evenly into 5. Likewise for the 2 and the 3. So in this case, I'm going to multiply both equations by something. Your choice. This time I'm going to choose the y's. I would like 2 and 3 can both go into 6. So I'm going to multiply the top equation by a 3. And the bottom one, since there's already a minus sign here, is going to be a 2. I'm going to write both new equations over here. Multiplying everything in the first equation by 3, we're going to get a 15x plus a 6y equals a 3. For the next one, we're going to have 8x minus 6y. 2 times negative 13 is a negative 26. And I'm going to draw my addition line. I wanted my 6y's to cancel, or my y's to cancel. Now they will because I have a 6y minus a 6y. My x's just go based off of the signs. They're both positive, so adding these, I'm going to get a 23x. 3 minus a 26 is a negative 23. I'm going to divide both sides by 23. So x is going to equal a negative 1. So right now, I've got the first part of my ordered pair. I need to find y. Does it matter which equation we use? No, I'm going to use the first one. 5x plus 2y equals 1, and x is negative 1, so 5 times negative 1 plus 2y equals 1. This will give me a negative 5 plus 2y equals 1. Add 5, so 2y is going to equal 6. Divide by 2, y equals 3. So this is my solution. This means I would have intersecting lines. Let's just check real quick. If I take 5 times negative 1, I'm going to check my first equation, plus 2 times 3, I do get a 1. This is negative 5 plus 6. That does give me a 1. If I check the other equation, 4 times negative 1 minus 3 times 3 equals negative 13. This will give me a negative 4 minus a 9. Negative 4 minus 9 is negative 13. All right, so this worksheet, I'll post this as a separate PDF. I just want you guys doing all of the evens, all of the evens. This is a mixture of solved by graphing. So I'll scroll through this. So 2 and 4 are solved by graphing. Then when you get down to the next section here, 6 and 8 solved by substitution. So are 10, 12, and 14. Now, if you do print this paper out, do not do all your work on this handout. Do this on a separate sheet of paper. Once you get to 16, 18, 20, these are all solved by elimination. 22, 24. Okay, so you have 12 problems to do. Like I said, I'll post this as a separate PDF. But especially with the solved by graphing worksheet from Monday that was due today, please let me know if you guys have any questions.